Hello participants, in this video we will discuss the solution to the problem magical sequence. So in the problem they have mentioned that they will give us a string S and we have to find the shortest magical sequence K that can be repeated multiple times to form a string, let's call it M, almost identical to the given enchanted string S. So in this problem, almost identical means at most one symbol can differ from the original and enchanted string S. So the string S and the string M that we will form should only differ in at most one position, and the size of string S and the size of string M should be equal. So we have to find the shortest magical sequence K that can be repeated multiple times to form the string M, which will differ from the string S at most at one position, right? So M will be formed by repeating K some number of times. So K will be repeated some number of times, and let us call the size of, let's suppose the size of K is equal to R, and let us say the size of S is equal to N. Now from this observation, and the size of M should be equal to the size of string S, right? So from this we can see that R should be a factor of N, otherwise it won't be possible to form a string of size N by repeating multiple times. For example, if N is equal to 8, R should be either 1, 2, 4 or 8. These are the factors of 8. Only by repeating strings of these sizes multiple times we can form 8. Otherwise, let's suppose we take a factor, we take a R which is not a factor of 8. We take an R is equal to 3, which is not a factor of 8. If we take R alone, it will be equal to 3. If we repeat R 2 times, it will be equal to 6. If we repeat R 3 times, it will be equal to 9. At no point is R becoming equal to the size becoming equal to the required N that we want. So the first observation is that R should be a factor of N that they give us. So this is the initial for loop. We have to iterate through all the factors of N initially. So this will be a for loop of time complexity root N. So this is the initial for loop, and going through iterating through all the factors of N will be only root and time complexity. I'll show you the code for that, and we have to check whether we can form a magical sequence K of these sizes. We have to check whether we can form a magical sequence, a valid magical sequence. A valid magical sequence is the sequence which can be repeated multiple times to form a string M, which will differ at most in one position from string S. String S is a string that they have given us. So to check whether we can form a string K using this using a string K of size these factors, there will be another O of N for loop. So the total time complexity will be root N into N, O of root N into N, and this will be well within the time limits that they have given us, right? Now how are we gonna do this? So how are we gonna check whether there exists a valid magical sequence K for each of these factors? Now I will give you an example. This is the example that we will choose. S is equal to A, B, C, A, B, E, A, D, C. Alright, and we have to find a magical sequence K which can be repeated multiple times to form a string M which is almost identical to string S, right? Suppose we are trying to make a magical sequence of size 3 right now. So r is equal to 3 right now. So this is a string of size 9 and 3 is a factor of 9, so we can choose r is equal to 3. So we want to check whether we can form a magical sequence of size 3 right now. Right now, when we consider this magical sequence, what all positions does this position in K affect in string S? So what position does this character in string K affect in string S? So we can see that when we repeat K multiple times over here, this is a K, this is a K, and this is a K, right? So we can see that this character will affect this character, and this character, because these are the first characters in K. So the first character in K will affect these characters in string S. And now what we are going to do is that we are going to take the character with the maximum occurrence from these characters that it is going to affect. So we are going to take the character with the maximum occurrence. We can see that the character with the maximum occurrence is A, right? And now we will check whether there is any mismatch between the character that we chose and the character at these positions. So we have chose A and the character at this position is A, so there is no mismatch. We have chose A and the character at this position is A, and the character at this position is also A. So there is no mismatch. So the difference currently is equal to 0 because there is no mismatch. The difference or the mismatch currently is equal to 0. Right. Now we will choose a character for this position. Now to choose a character for this position, we have to consider these characters. Right. So I will give those characters number 2. So the character 2 in K will affect these characters in string S. Right. And now here also we will choose the character with the maximum occurrence in string S. So here we will so out of all the characters that character 2 affects, B is the character with the most occurrence. So we will write B over here. And now we will see whether there is any mismatch between this character and the character that it affects in string S. So there is no mismatch over here, there is no mismatch over here, but there is a mismatch over here, right? So here it is D, but we have chose B, so there is a mismatch over here. So the difference now is equal to 1. And in the problem it is mentioned that they will allow us a difference of at max 1. The difference can't go below 1. So till now it is fine. Till now it is a valid sequence that we are creating. Now we will consider the third position. The third position will affect these characters. Okay, out of the characters that it affects, the character with the most occurrence is C. So C is character with the most occurrence. So we will write C over here, right? We will write C over here. Now we will check whether there is a mismatch between C and the character that it affects. So there is a match over here, but there is a mismatch over here, there is a match over here. So there is one mismatch. There was already one mismatch by B and there is another mismatch by C. So the number of mismatches or differences now becomes equal to 2. But since in the problem it is mentioned that there can only be at max one mismatch, we can't this is not a valid magical sequence. So we know that there can't be no magical sequence with the size r is equal to 3. Now similarly we have to check for all the magical sequences with the other sizes as well, and we will print the size of the valid magical sequence which is the smallest. So that is the explanation to the entire problem. Now I will show you the code. Hello guys, now I will explain the code for the problem. So this is the code for the problem. I will zoom in a little bit. So here we are inputting size n, string s, and I am initially declaring the answer as n because we know that the answer can at least be the size of string s, because if we choose k as string s itself, we will always get an answer, valid answer. So we have to check whether there is an answer lesser than size n. And now we are in the first for loop, we are iterating from 1 to root n. This will be useful for iterating through the factors. So for each I, initially I am checking whether I is a factor of n or not. If I is a factor of n, n modulo I will be equal to 0. And here I have declared the difference variable to store the number of mismatches. And I am iterating the size of, iterating through the size of 1k. So in the solution I told you we will iterate till n. Okay, like in this first for loop we are only iterating till I, but like there is a for loop, a while loop inside that. Okay, that will be used to iterate the rest of the distance. And now I am using a map to keep track of the number of occurrences, which will help us keep track which character has the maximum number of occurrences. You can use a dictionary in Python also, and inside this max variable I'm going to store the number of occurrences of the character with the maximum number of occurrences. And so I am iterating the rest of the n inside this while loop. I am now, and I am incrementing the count of each character, and I am storing the character with the maximum occurrence in this max variable, the occurrence of the character with the maximum occurrence. And then I'm incrementing inc, or the increment variable, and then the difference will be I am incrementing the distance as the difference as. So we know that the total number of characters for each position will be equal to n by I. Suppose if we are considering for a string s of size 8, and the k that we are considering is this I is equal to 2. So for each character in I, the number of characters it affects in a string s will be equal to n by I. So since I is equal to 2 and string s is equal to 8, the number of characters each character in k would affect is 8 by 2, it will be equal to 4. So we know that each character in k will affect 4 characters in n. So that's why I'm so to find how many characters is getting affected by each character in k, I am doing this, and I am subtracting max from this. So this will help me in calculating the number of mismatches. You can see this with like by trying out an example. So this will help me in finding the number of mismatches. And now I will check whether the number of mismatches is lesser than or equal to 1. If it's lesser than or equal to 1 after after trying going through iterating through all the positions and all the characters, then we have a valid answer, and I will put answer is equal to minimum answer comma I, where I is the factor that we are initially considering. And we also know that n by I is also a factor, right? If I is a factor, n by I will also be a factor. So we will also consider for n by I, and now I put that in a variable called f. So I'm doing the same thing again for n by I, doing the same exact code, but I am just replacing the positions with the I with the f. That's it. So at the end I am outputting the answer. The answer will contain the length of the shortest magical sequence that we can form. Yeah, that's about it. Thank you for listening into this solution. Bye. Difference can't go below 1. So till